Hi, we are Group 13, the Rules Node team. In this video, we will walk through our UI mockups, the MVVM diagram of our projects, the progress we've made so far, how we divide the work among team members, and our plan for the show and tell too. Our app basically uses AI to pull information from multiple sources, so it can recommend the places in a much more specific way than Google Maps. For example, it can suggest the restaurants with lighter flavors or libraries where you can plug in your laptop. And on top of that, the app helps users build personalized routes based on their own preference. As you can see, this is a real problem people face. Now, I would like to show you our UI mockups. When the user first opens the app, they will see the login screen. If they don't have an account yet, they can tap Register Now to create one. We only ask for three things: their full name, a unique email, and a secure password. Once they enter the correct email and the password, they will be taken to the main interface. Here we have a button tab navigator, and the user can switch between screens using the tabs. On the search screen, the user can ask the AI for suggestions about the places near a certain destination, places like restaurants, bars, or gyms. You will notice that we start with one route node. The number refers to the order of stops in the user's day. The user selects this number from a drop-down, and the numbers are always unique. So if you tap the green plus button, a new route node appears. The new one starts as number 2, meaning this is the second stop. The user can also change the number manually, and we use a swap strategy to keep numbers unique. For example, if we have 3 nodes and we change number 3 to number 1, then the original number 1 becomes number 3, while number 2 stays the same. If there are 3 or more nodes, a delete button appears in the top right corner of each node, so the user can remove it if needed. Location represents the general area the user wants to go to. When tapped, it opens a pop-up where the user can type in an address or pick one of their common locations, which are set in settings. This field cannot be empty. The place you are looking for is what the user actually wants, like a restaurant or a gym. This field cannot be empty. Distance represents how far the suggestions should be from the location. It can be empty. Additional requirements can be anything the user wants to add. It can also be empty. So after filling everything out, the user taps Ask AI for advice. The AI will return a formatted response. If users don't like it, they can tap Retry to generate a new one. If users do like it, they can tap the heart icon to save it to favorites. Since we want to control cost and complexity, we are not implementing chat history. So previous results are not saved unless the user manually favorites them. On the favorite screen, the user can see all the responses they've saved, and the default name of each favorite is based on the location and the place you are looking for. If the user wants to rename it or edit the content, they can tap the expand buttons on the top, and they can also delete the favorites. And the search bar allows the user to search favorites by name. In the account screen, we show the user user's profile, their avatar, name, and email. Under My Profile, they can change personal info. Under Setting, they can change their password, switch the theme mode, and add common locations like home or SFU. So those features are pretty standard. You can find them in many apps. What I really want to show you is our AI model page. When you tap into this page, you will see that the user can choose which GPT model they want to use. And we also allow the user to control the creativity level of the AI response. This is a float number between 0.2 and 1.2. Basically, the higher the value, the more imaginative and flexible the answer will be. Then we also let the user set the response length anywhere from 400 to 800 characters. And of course, users can log out. When the app launches, we start in main activity. The main interface uses a button tap navigator to switch between the three fragments. In AI search fragments, the user can add multiple root nodes. Since each node has the same UI layout, we use root node adapter to manage and display this dynamic list. When the user fills in the information and asks for AI suggestions, the fragment doesn't handle the logic directly. Instead, it sends the input to AI search view model. The view model prepares the request and calls AI search repository. The repository is responsible for communicating with the OpenAI API, getting the AI-generated suggestions, and return the result back to the view model. Finally, the view model updates a piece of live data, and the fragments observe this data and automatically refresh the UI when it changes. Similar to AI search fragment, in favorite fragments, the user can view all the routes they've saved before. Since this is also a list of repeated items, we use favorite route adapter to display the list. The screen observes data from favorite view model. The view model manages the list state and handle users' actions like deleting a favorite or renaming it. When data needed to store or load it, the view model calls favorite repository. The repository is responsible for reading and writing data, and it uses Firebase as the backend storage. In account fragment, the user can view basic profile info and navigate to other pages. All of these fragments relies on account view model, which manages the user's data and action. The view model calls account repository, which handles loading and saving data to Firebase as well. Now let me show you what we have done so far. We add a button tab bar to make navigation simple. There are 3 tabs: Search, Favorites, and Accounts, and the app opens on Search by default. You can tap a tab or swipe left and right to switch fragments. And the active tabs turn screen so you always know where you are. In Search fragment, we've implemented root node creation. When you tap this green button, a new root node appears. And as you can see, the number automatically increments by 1, and the swap rule still works. And all the input fields are functional. Because the original idea we had in Project Peach turned out to have some issues, we end up removing a lot of code that was no longer relevant. So for now, we only implement these features. For task division, Kunlong, myself, I will handle all the AI-related work, including API codes, prompt engineering, and model configuration. Erik and Jun will work together on the favorite CRUD features. Lee and Tushar will be responsible for user login, profile editing, and the settings page. So our plan for show and tell 2 is, first, we will implement user login and personalization features. And second, we will set up the database connection and complete CRUD operations for favorites. And third, we will call the OpenAI API and use prompt to guide how the AI responds. And last, which is optional, we may try integrating the Google Maps API to recommend the public transit route.